Today we're going to take a look at some applications of linear functions, how we can take a real-world situation and model it with an equation. So with a linear function, the thing that's going to identify it versus anything else is that change is always at a constant rate. Things always change at the same rate every time the same amount is added. This is the slope, or the m, of our equation. The question you need to decide is if you should use the point-slope formula or just the slope-intercept formula. How we decide is if we know the starting point, which is the y-intercept or the b, and the rate of change, or slope, we can use the slope-intercept form. The key thing that we need is the starting point. What happens at 0? If we don't know the starting point, we just know a point and a slope, we can use the slope-intercept equation. And by now you should be familiar with both of these equations. The only other possible situation is if we know 2 points, we would first have to figure out what the slope is using those 2 points, and then we can use the point-slope formula. So let's see if we can make a few equations to model some real-world data. First, you're going to start out with $150 in your bank account. You're going to save $28 a year. What equation will model your savings? This isn't growing very fast, but let's see what we have. So this $150 is what you start with. This is the starting amount. That is your y-intercept. The y-intercept is where you start. We save $28 a year. That is how it's changing. Every year we add 28, add 28, add 28. The change is always your slope. So we know the slope-intercept equation is y equals mx plus b. And because we know where we start at 150, we just have to plug in what we know. Y equals m, my slope, the $28 a year, times x plus b, which is the $150. And this equation will tell us how much is in our savings account after 2 years, 3 years, 4 years, and 5 years. Contrast that with this example. Here we have a 3-month-old child who weighs 14.9 pounds. And it's expected that he's going to gain 2.4 pounds each month. What equation could model the child's weight? Well, here we don't know what weight the child started at. We know that at 3 months, he weighed 14.9 pounds. We combine that with an x and a y. At 3 months, he had 14.9 pounds. We have a point, 3, 14.9. We also have this fact that he will gain 2.4 pounds each month. That's the change. We're going to add 2.4 every month. That change is the slope. So we've got a slope that's equal to 2.4 pounds. So we don't know where he started. We have to use the point-slope form. Y minus y1 equals m times x minus x1. Plugging in what we know, y minus y1 is 14.9 equals m, 2.4, times x minus x1, which is 3. And this equation will work just fine unless we were asked to do it in slope-intercept form. So if we were asked to do it in slope-intercept form, we would distribute the 2.4 through, and we would get 2.4x minus 7.2. And then we would finish it off by adding the 14.9 to both sides, and we would get y equals 2.4x plus 7.7. And now we have an equation to model the weight of this child after so many months. One more example. You find out that a 5-minute taxi cab costs $8 and a 10-minute taxi cab costs $12. We want an equation to model the taxi ride cost. Here we don't know how the price is changing exactly. We don't know that it changes 28 cents per minute or something like that. We just know A 5-minute taxi ride corresponds with an $8 ticket. And a 10-minute taxi ride corresponds with a $12 ticket or price. We really have 2 points. 5 minutes is $8. And 10 minutes is $12. We have x1 and y1, x2 and y2. What we need to first find is the slope. Well, slope we know is y1 minus y2 over x1 minus x2. So let's plug this in. y1 is 8 minus y2 is 12 over x1 is 5 minus x2 is 10. 8 minus 12 is negative 4. 5 minus 10 is negative 5. 2 negatives make a positive. So the slope is 4/5. And now we're ready with a slope and a point to use that point slope form. Y minus y1 equals m times x minus x1. So let's try and plug in what we know. Y minus y1 is 8 equals m. The slope we found is 4/5 times x minus x1 is 5. And that might work unless we were asked to give the equation in slope-intercept form, in which case we'll distribute the 4/5. Y minus 8 equals 4/5 x minus 4 times 5 is 20, divided by 5 is 4. And finally, add the 8 to both sides. And y is equal to 4/5 x plus 4. This will model the taxi ride cost. So now we could say if we went on a 20-minute ride, we plug 20 minutes in for x, and 4/5 times 20 is 16, plus 4 is $20. So that's how we can do applications of linear functions. If we know the y-intercept, we'll use the slope-intercept form. If we don't know the y-intercept, we'll use the point-slope form, and we may have to do a little work to actually find the slope. So take a look at your homework assignment and let your instructor know if you have any questions.